This lesson covers surface area of prisms and cylinders. Number one is a box, which is also called a rectangular prism because the base of it is a rectangle, and it's a prism because it goes straight down. What I did on this one is I divided it up for you to start thinking about how we can develop a quick formula to find the surface area of a rectangular prism. So on the right side here, we have 4 by 4 are 16 check marks. The other side that's parallel to it is going to have the same amount of them, so we need to multiply that by 2. The front and the back are going to be the same, and it's got 2 by 4 or 8 X's on it, so there's going to be the same amount of it on the back. And then the top is also 4 by 2 or 8. And again, we got the top and the bottom, which are going to be equal, so that's also by 2. So altogether, we have 32 plus 16 plus 16 or 64 squares there. Each square is 1 by 1 or 1 centimeter squared, so the total surface area is 64 centimeters squared. Another way you can think about it, instead of what I did by adding up all of the sides individually, is you can use the surface area formula for a prism, which is pH plus 2b. P stands for down here, the perimeter of the base. H is the height of the prism between the parallel bases, and capital B stands for the area of the base. So the perimeter of the base on this rectangle here, the base I'm calling the top and the bottom. You could pick any two sides that are parallel to each other, but I'm going to call it the top and the bottom. So the top and the bottom have a perimeter of 4, 2, and another 4 and another 2. So it has a perimeter of 20. No, let's see. 4 plus 4 is 8, 10, 12. It has a perimeter of 12. And then times the height. H is the height of the prism between the two parallel bases. Between the top and the bottom, it's got a height of 4. 1, 2, 3, 4. And then capital B stands for the area of the base. And the area of the base is 4 long by 2, or 4 by 2, 8. So you could have also done the 2 by 4 times 2, and that gives you that same answer of 64. We're going to use that formula quite a bit, so you'll get a lot faster at it here with me. All right, so doing the next one here, I want to show you another fun way to find a rectangular prism. This only works on boxes or rectangular prisms. You could take the length, width, and height of so that's 7, the 4, and the 9. You take those three numbers, and you can make a heart out of it. So 7 times 9, 63, 9 times 4, 36, and 7 times 4, 28. And then double it, and that gives you all 6 sides added together. Or, using that other formula that I just talked about, pH plus 2b, the perimeter of the base, again, I'm going to call the bottom of it here the base. So the base is 9 on both sides, or 9 times 2 and 4. So the perimeter of it is 9 times 2 plus 4 times 2. And again, the height is the height between the two bases. So I called the bottom rectangle a base. And so between the top and the bottom rectangle, the height between them is 7. And then again, capital B stands for the area of the base. And the area of the base here is 9 times 4, or 36, which also adds up to the 254. And again, if you wanted to, you could broke it down to all 6 sides like we did up above and just add all 6 sides individually. On number 3, they gave us a nut. What you can do on the nut is you can print this out and then cut around the whole outside of it. And then what you can do is fold it all together to make that box. It's kind of fun, honestly, and if you have some younger siblings, they'd probably get a real kick out of doing it too. It's pretty good entertainment. So taking a look here, again, I'm going to call the top and the bottom the bases. Any two sides that are parallel are the bases, but I'm going to go with these two as being the bases. So this side was 8, which is right here. So all of those are 8. I put squiggly lines here because I don't want to count it twice. Here's the 8 and there's the 8. And when you fold it all up, that side that's 8 is actually the same side as you're like double counting it. You'll see it again when you fold it all up. So again, I would really highly suggest just take this whole thing, fold it all up to make that. That's 8 by 3 by 11. A lot of the times there's been a lot of research on it that you guys have not played with Legos that much, so you have a hard time visualizing things three-dimensionally. And a lot of times you haven't even rolled a dice. You don't even understand that a dice has 6 sides. So if you're really having troubles with it, please print it off and cut it out and fold it together to make the shape on the left. And then you get all those side lengths. And then it says use the net to find the surface area. Again, on the actual numbers, it's 3 by 8 by 11. You could use either one of those two methods I talked about before. You could do the heart method with those 3 numbers, 24, 88, and 33, and then double it for the whole answer of 290. And you could use pH plus 2b. The perimeter of the base, I said this rectangle down here is the base, so 8, 8, 3, and 3 are 3 times 2 and 8 times 2, and the height between those two bases up here, the height between those two bases was 11. And then plus, then 2 times the area of the base. So 2 times the area of the base, and the base is that rectangle on the bottom here, which was 8 by 3 or 24. So it had an area of 24, which also gives you the answer then of 290. Number 4 is pretty much the same thing. Again, you might want to think about, if you haven't done it yet, is another example of where you could print this off, cut it out, fold it together, and you got yourself your box. It's kind of fun, it really is. All right, so using the net to find the lateral surface area. Okay, so they also, like I was, they're calling the top and the bottom the bases. So the lateral area is the sides that are not colored blue. It's the other 4 white rectangles. So the lateral surface area would be the left and the right side of the box and the front and the back. So the left and the right side of the box are 10 by 4. And then the front and the back of it, the front is 7 by 10 for the front rectangle, 7 by 10. And again, the back's equal to it. That's why it's times 2, which gives you 220. Or again, you can use that formula pH. So the lateral surface area is just the pH part of the formula. The perimeter of the base is 7 times 2, 4 times 2, and it'll give you the whole perimeter of the base. And then the height, again, is how far apart the two bases are, and the two bases are 10 apart, which also gives you the 220. And then the whole surface area then is the lateral area, pH, which was 220, and then add on that the area of the two bases. Capital B stands for the area of the bases. Again, going back to the formulas that I had on the first question here, what the letters stand for, P is the perimeter of the base, H is the height of the prism between the parallel bases, and capital B stands for the area of the base. All right, then adding them together, you get the 276 centimeters squared. Okay, number 5 wants to know, a company made a storage container with sheet steel walls. The container was in the shape of a rectangular prism as shown below. Suppose the total cost of the sheet steel was $4,760. How much did the sheet steel cost per square foot? I want you to say that word fast 10 times. Yeah, you can't do it. I knew it. All right. So they want the cost per square meter. So money per means divide the meter squared. So the cost they told us is $47.60. We need to find out how many meters squared we have of the sheet metal. Well, it's 8 by 4 by 3, so I'm just going to do the quick thing that make the hard out of the 3 numbers. So you got 32, 12, and 24. Double it for all 6 sides, you have 136. So divide by your meter squared, and that gives you $35 per meter squared. All right, number 6 actually went on for a while. Here on to the next page too. It says Juan is planning a texture coat of building whose dimensions are shown below. Look, I found it. Oh, no, it's actually on the back. We'll have to flip to it. The front of the building has a window measuring 4 feet by 30 inches and a door measuring 40 inches by 6 feet. The left and right sides of the building each have a window measuring 20 feet by 4 feet. The back of the building has no window or door. All right, I put those numbers on the picture here on the back. So we're going to want to find the surface area of this building, just the four walls, the front, the back, the left, and the right side. We don't care about painting the roof or painting under the building. So the front of the building here is 18 by 10, and the front and the back are equal, so times 2. The left and the right sides of the building are both 28 by 10, and again, there's the left and the right, so times 2, and that gives you 920. We need to subtract off the window and the doors, so we got the window here that's 20 by 4, and there's 2 of them, because they said there was 2, one on the left and the right side, so times 2. And then minus this window here, which is 4 feet by 30 inches. So again, pay attention to the units. It's all in feet, and so we need to change this to feet. And there's 12 inches in a foot, so I divided that by 12. So this window is 4 by 30 divided by 12. And then last of all, we got the door, which they also gave us on inches. So we're subtracting off that rectangle. So 6 times the 40 inches, and again, we need to change the inches to feet, so I divide by 12. And then that gives you 730 feet squared. So that is your answer on letter A. They want to know how many feet squared there were in the picture. There was 730 feet squared. And then on letter B, Juan bought some paint, and it takes 130 feet squared in 1 can. Well, we had 730 feet squared, so divide that by 130, and we got to buy 5.61 cans. Again, we can't buy a part of a can, we got to buy all the cans. So round it up, and that gives you 6 cans. So we bought 6 cans that each cost $12.50, so that's $75 before tax. If you actually went up to the register, we both know it costs more because they're going to charge a tax. Number 7, can't really use a formula for this one because it's an irregular shape, so you got to break it all up. And they want the surface area of all of it, and each one of them is a perfect 1-inch cube. So I did the front of it, which is 3 by 4, which gave you 12. And the left and the right are going to be equal to each other. They're going to be mirror images. So there's 2 of them, the left and the right side. And I just counted them up. We got 4 times 5, so 20, 1, 2. So there's 22 squares here on the left. So there's 22 on the right. So that's why that's times 2. The top of it, I highlighted it with yellow. So we got 3 by 3, 9. And then we've got the very top, which is 2 by 3, 6. And we got that little piece right there, which is 3. So that gives you the highlighted pieces that we can see there of the top. And then we got the back of the box. And the back of the box is going to be 5 high. And then it's going to be 3 deep. It's 3 across, so the back of it's 3 deep. So 5 by 3 for the back. And then don't forget the bottom of the darn thing. The bottom of it's going to be 3, 5 across, and then 3 this way. So the bottom's 5 by 3 or 15. So add them up. 12, 44, 18, 15. 15 adds up to 104 inches squared. All right, number 8, mixing it up. We have a triangular prism this time. So the 2 parallel sides are these triangles on the left and the right. I went ahead and added up the actual pieces first, and then we'll use the formula pH plus 2b on it. So adding up the pieces, we have the rectangle in the very back that is 7 by 5. We got the left and the right triangles that are 12 by 5. Again, the area of a triangle is 1/2 the base times the height. And the base and the height are the 2 sides that make the right angle. And the right angle is right there. So 12 and 5 are the base and the height. And it's times 2 because the left and the right side, there's 2 parallel sides that are equal. And then don't forget to add up the top of it. The top rectangle here is 13 by 7, which adds up to 270 feet squared. Or again, just use the formula for a prism, which is pH plus 2b for the surface area of a prism, perimeter of the base. The base are, again, the 2 sides that are parallel, which are the 2 triangles. They're parallel to each other. So the perimeter of it's 12, 5, and 13. It's 13 because that's 13. So that's the whole perimeter. And then the height is how far apart the 2 bases are. And the 2 bases are 7 apart. And then we have to add on the area of the base. And the bases, again, are the triangles. And so the formula for a triangle is 1/2 base times height the base and the height, two sides that make the right angle, 12 and 5, and that gives you 270. So you could add up all the sides individually, or you can use that pH plus 2b formula. It doesn't matter. Doing the same thing on number 9, pretty much. I think they were trying to help us understand the formula and where it comes from a little bit when we did this one. This one's also super fun to cut up. You can just cut up the outside edges and you'll be able to fold it into the triangular prism. I think honestly, just it's like doing a little origami. It's super fun, and then when you get kind of angry and you're done playing with it and making the figure, you can smash it. That's always fun. You know you will. You will definitely smash it. All right, so this one's really honestly the same formula as before after you figure out what all the sides are, which again, cut it out, put it together. You'll be able to see what the sides are a lot easier that way. Okay, so our bases again are the two parallel triangles, and the two parallel triangles, if you go around the perimeter of it, 6, 8, and 10, and the height between the two bases is 4, and then the area of the base, the 6 and the 8 make the right angle, so that's the base and the height of the triangle. So 1/2 base times height, so 1/2 6 times 8, and you get the whole answer is 144. Number 10. It's also the same thing again. It's another triangular prism. So again, this one's fun. It's really fun because they got the two colored pieces to highlight that those are the triangular bases, which makes it kind of fun to cut that one out and fold it up into that triangular prism. I think you'll have some fun doing that. And it's all the same formulas as before. So the perimeter of the base is 3, 4, and 5. And then the height between the two bases is 7. And then the total surface area, adding on the area of the base, and the base here again is 3 by 4 for the height, and the base and the height of it, 1/2 base times height, area of a triangle. There's the right angle, so 3 and 4 are the base and the height. And again, there's 2 of them, that's why it's 2b on the formula, and it gives you 96. Number 11. Number 11, they're mixing it up. Now they got a cylinder. I was kind of sad that they didn't give you a cylinder to cut out. How you get a cylinder is if you cut it right here and you unroll it, it makes a rectangle. So if I took this piece of paper and I rolled it up, I have got myself a cylinder now. And when you unroll it, that is the circumference right there. When you unroll the top of it into the rectangle, you got the circumference. So the formula is still the same, pH plus 2b. Here, the perimeter of the base is the circumference of that circle. Remember, circumference is 2 pi r, or pi d, and then plus the area of the base. The base is a circle, so the area of a circle is pi r squared. So we have pi dh plus 2 pi r squared. The diameter of the base was 4. The radius of the base is 2, half the diameter 2. And so you get 24 pi and 8 pi, which would give you the exact answer, 32 pi. They didn't want the exact answer. They wanted you to put in 3.14, and that gives you 100.48 inches squared. And number 12 is the same question. They wanted you to put it in terms of pi, so that means leave the pi this time. Don't plug in 3.14, just leave it. So again, the formula pH plus 2b, p is the perimeter of the base circumference, pi d, area of the base, pi r squared. The diameter is 4, the radius is 2, so you get 16 pi and 8 pi. So just like the letter X, you got 16 X's and 8 X's, so you got 24 X's, or 24 pi's. Number 13, a company makes paper labels for cans of soup. As shown below, each can is in the shape of a cylinder with a height of 8 centimeters and a diameter of 6 centimeters. The paper label is wrapped around the can and covers only the side of the can, not the top or bottom. If the company makes 15 labels, how many square centimeters of paper will be needed? Use 3.14 for pi. Do not round your answer. Okay, we don't need the 2b this time because we're not putting paper on the top and bottom of the can. We just want to know the lateral area of a pH that would fold up. Again, when you fold up the rectangle, you get yourself the cylinder shape. And so we just care about the perimeter times the height. So the perimeter is pi d, circumference, pi d, and then times h. The diameter is 6. The height between the two bases is 8. So that gives you 48 pi. And they said we want 15 of them. So we got to multiply that answer by 15, and I put in 3.14 for pi, which is 2,260.8 centimeters squared. 14 was a little upsetting to me. It was about a mailbox. We got our mailbox smashed a couple weeks ago and had to buy a new one. It was kind of sad. We bought one with some really solid steel, so the next time he hits it, it'll do some damage. Someone else in the neighborhood also got their mailbox hit, so I don't know. We'll ponder it here for a second, then we'll go back to the work. They're either drunk, they're texting, they're old, or they're just stupid. I don't know. Take your pick. All right, I still use that formula, pH plus 2b here, to find the surface area of the mailbox. So pH plus 2b. So the perimeter of the base here of the mailbox, I highlighted it in yellow. It's going to be these three sides, which are 0.5, 0.6, and 0.5 again, and then plus this half a circle up there. So we don't want the whole circumference, we just want half the circumference. Circumference is pi d, and we just want half of it for that half of a circle. And the diameter was 0.6, and so it gave me 0.3 pi for the arc here. So the arc's 0.03 pi. And then the height between the two bases is 0.65. So if you do the math on that, it gives you this number, 1.6253, and then plus the area of the two bases, which I did over here. The base is, the area of it is that rectangle plus the area of that half a circle. So the rectangle was 0.6 by 0.5 for the area of that rectangle, length times width, and then plus half the area of the circle. Area of a circle is pi r squared. The radius is going to be 0.3 because that's half of that side's 0.6, so halfway over is 0.3. So 1/2 pi r squared, and so it's 0.3 squared. So when you do the math and add it up, it's 0.8826 when I use 3.14 for pi. Add them together, one mailbox is 2.5349 for one mailbox, and you need to buy 1,388, and so that's 3,519 meters squared when you round up to the nearest meter. 15 is a pyramid, kind of fun. So you've got the area of the base, which they colored blue, and it's 4 by 4 for that square, 16. And then you got all the triangles, which are all equal because the base is a square, and so they're all 4s. So the area of one triangle, the base times the height of it, they give you the height down here is 5.3. So the base is 4, the height is 5.3. So one lateral face, or one triangle, 1/2 base times height is 1/2 4 times 5.3, or 10.6. But they also want to know, how about for 4 triangles? So multiply that answer before by 4, and you got all 4. So the total surface area would be the 4 triangles, 42.4, plus the one square base, which was 16, which gives you 58.4. Last one, we're going to paint a monument. We're not going to paint the inside of the monument. We're not going to paint the bottom of the monument. We want to paint the 4 rectangles going around it and